For our example, we are going to use sample problem 2.3 on page 33 of your textbook. You can read that one. I'm going to write here only the summary of the given. So, we have f sub 1, and a vector f sub 1, which is 4.0 newtons. Vector f sub 2. Alright, so we need to find the resultant vector. First step is we are going to create or make a scale. Or the scale is depending, or your scale is depending on your, or the tool that you are using. Since I am using a meter stick and a bigger protractor, my scale is obviously different. It will be obviously different from yours. I will be using the inch. Para hindi kayo gamay, likod kayo. Ako, ugo lang. So 1 inch is equal to, the unit here is Newton. So 1 inch will be equivalent to 1 Newton as well. The scale here helps us represent the unit Newton while we are using the unit inch. Okay, so let's start. Draw the arrows representing the vectors from a common point. We need to create a common point by doing or putting the Cartesian plane. Okay, our common point is of course the origin. Okay, first, our f sub 1, or vector f sub 1 is 4.0 newtons directed east. Where is east? East is right here, this side. West is north, south. West is there, north, and then south. Our first given is 4.0 newtons directed east. Since I am going to use inch, since I'm using inch, I am going to measure how many inches. Of course, we have 4 because 1 inch is equivalent to 1 newton. Since we have 4 newtons, I need to measure 4 inches here. Then, always, I'm going to take out E. Always put an arrowhead. Without an arrowhead, that is not anymore a vector. Okay, next is f sub 2. F sub 2 is 6.0 newtons directed northeast. Where is northeast? It is perfectly in the middle of north and east. This time I am going to use a protractor to make sure that it is really 45 degrees between north and east. This protractor is quite hard to handle. Where is 45? It's here. have to be careful in measuring because single error will create uncertainties in your measurement or in the result of your measurements. Okay, so we have already traced the direction which is northeast. Now we are going to measure 6 newtons. Since we are using a scale, we have 6 inches. This one is f sub 1. This is vector f sub 2. Okay, so since we have 3 vectors here, again we are going to apply what property? It is the associative property. We have f sub 1 plus vector f sub 2 plus vector f sub 3. We can have it grouped as f sub 1 plus f sub 2 and the result added to f sub 3, which is, okay, r sub 1 are the resultant of these 2 vectors added to f sub 3. Or you can have it f sub 2 or group it as f sub 2 plus f sub 3 and then the result of this added to f sub 1 depending on your preference. So in this discussion, I'm going to use f sub 1 plus f sub 2, group them together and then the result added to f sub 3. Okay, so second step is construct a parallelogram using the 2 vectors as sides. So from these 2 vectors, f sub 1 and f sub 2, I'm going to construct a parallelogram. How do I construct a parallelogram? Using these 2 as the sides. That means f sub 2, I'm going to create an opposite line of f sub 2, which has exactly the same measure of f sub 2. It's like an identical line which is opposite of f sub 2. To make it sure, I'm going to measure again 45 degrees. Para di ka matalang. Okay, so the opposite of f sub 2 should be connected to f sub 1 or the tip of f sub 1 and then represented by a broken line to tell that the opposite line is not the vector itself. Para dili mo maligo. Okay, you don't have to put an arrow because that is not a vector quantity. And then same with f sub 1. We are going to create an identical and opposite line of f sub 1. Again represented by a broken line without an arrow, of course. Okay, right after, we are going to proceed to step 3. Draw the diagonal of a parallelogram from the common point. This represents the resultant R. So from here, we are going to draw the diagonal from the common point. Our common point again is located in the origin. Okay, so this diagonal line has to be represented by a bold line with an arrow because it is already the representation of the resultant vector. Okay, as what we can see, we have here 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 inches. That means the resultant of f sub 1 added to f sub 2 is equal to 9 newtons. So this is represented by r sub 1, since this is not yet the final resultant. Okay, our final resultant will be taken when we add r sub 1 to f sub 3. Okay, now f sub 3 is, I forgot to represent this one well. F sub 3 is 8 newtons directed south. No need to use the protractor. I am going to measure directly 8 inches from the origin going to the south. Alright. Okay, so same thing. Same process with the addition of f sub 1 and f sub 2. We are going to go back to step 2, constructing a parallelogram. Since we are now dealing with r sub 1 and f sub 3, ito na rin kalimutan sa temporarily si f sub 1 o si f sub 2. We will focus on r sub 1 and f sub 3. Okay, so in doing or in creating a parallelogram, we are going to draw an identical and opposite line of f sub 3 because it is easier than r sub 1. Okay, directed south, represented by a broken line. And that is 9. It's 8. 8 newtons only. So it's only until here. No arrow. Okay, next is the identical and opposite line of r sub 1. Let's I'm going to draw this directly and figure out the direction, the angle later. Okay, this is the opposite and identical line of our sub 1. The next is drawing again the diagonal from the common point. The common point again is in the origin. And then measure. This is already the final resultant. Okay, this is vector R. Okay, let's count it again. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 newtons. And for the direction, okay, since this is in between east and south, we are going to start counting from east going south. We have okay, 25 degrees. 25 degrees south of east. Alright, for the final answer, the magnitude for our resultant is 9 newtons directed 25 degrees south of east. Okay, so that is how you find the resultant vector using the parallelogram method. Next method is the polygon method.